Okay, good afternoon, everyone. So hopefully you have downloaded the problems for the week 1 tutorial. So this one is the problems and you can get it from Moodle. So we start doing from problem 1. We start from problem 1, yeah? So anyone have tried the problems? Any of you have tried the problems? So so what did you expect from the following MATLAB commands? So you can type it in and you can see the commands and you can see the outputs, yeah. But now the question is, we have to understand what is going on, okay? So let me, so any of you have tried to put it in? So have anyone tried those commands? Okay, so now maybe let me start with the formula first before we put in the commands, yeah? Okay, so but why we get one I for this? So let me explain why we get one I, yeah? So let me share the piece of paper. So suppose you have the first command is, you can see my paper, yeah? The first command is just e to the pi over 2 pi pi over 2i, right? And if you remember, this is just an Euler formula, right? So this one, when you plot it on the complex plane, so this is a real imaginary axis, and e to the pi over 2i is just this point. Okay, so just I. That's why when you put in MATLAB, give you I. Okay, and the second command is just e to the pi over 2i. Okay, and if you remember your complex numbers in first year algebra, then this one is just e to the minus I pi over 2. Okay, and in the complex plane, just this point, and so therefore it will be equal minus I. Okay, so you can try to put it in. And now the next question will be, so the next question will be EPS. So what is EPS? So if you remember, EPS is the var epsilon, in the floating point number system. So if you listen to my lectures in the morning, yeah, then so you can type EPS into MATLAB and you can see it will equal 2.2 10 to the minus 16 something, okay? But so remember, in the floating point system, we have a plus and a minus sign for the first bit, yeah? And you have the exponent, okay? And then you have the significand, yeah? Okay, so we have 1 bit for this question. Any question? Okay, so no question, yeah? So remember, we have 1 bit for plus or minus, yeah? And then we have 11 bits for exponent. And remember, in MATLAB, we just assume everything in double precision. So totally, we have 64 bits. So therefore, the significand is 52 bits. Okay. So now if you represent number 1 in the floating point system, this one in decimal, right? So then you will see that it will have the form 1.00, like many zeros, okay, times 2 to the power 0. 2 to the power 0, just 1. So now, because the significant here is 52 bits, yeah, so we have 52 zeros here, okay? And now 1 plus epsilon, it just, you turn on the last digits from 0 to 1. So think of your car odometers, yeah? So if you remember the last digits, when you run to the next kilometers, it will just, jump to the next number. So here, because we have only 0 and 1, so after 0, then got to 1, okay? So then epsilon, it just, so this one is in binary form, okay? So epsilon is just 0.000 up to 1, okay? Multiplied by to the 0. So this one is 52 digits, okay? And then if you write down in terms of decimal, that's where we 2 to the minus 52. Okay, so it's just a gap between 1 and the next machine number in the floating point system. So now I show you MATLAB, yeah? So if I stop this and I share with you my MATLAB windows, then you will see what I'm talking about. So please ask question in the chat box, okay? So if you want to ask anything, because otherwise it will be very sleepy. Okay, so you see that this is my MATLAB, yeah? So now if I put in 2 to the minus 52, then I got this number. And I put EPS, then I got this number. So it's the same. So it's about 2.2, 10 to the minus 16. Okay. So now, so epsilon is the gap between 1 and the next machine number. So you will see the consequence. So now if I put in 1 plus epsilon over 2, okay, and I ask MATLAB whether it's bigger than 1 or not. So what is the answer? 0. Why is that? It's 0. But why is that? Because epsilon is the gap between 1 and the next machine number. So epsilon over 2, is too small for MATLAB to manage. So it treated like 0. So 1 plus 0 cannot be bigger than 1. Yeah. But be careful if you take 1 plus 0.75 of epsilon. So 3, maybe 3/4 of epsilon. Yeah. And you say that bigger than 1 or not? I say yes, because 3/4 of epsilon, they will round it up to epsilon. And 1 plus epsilon is indeed bigger than 1. Okay. So be careful about that. So epsilon is just a gap between 1 and the next machine number in the floating point system. Epsilon over 2, yes. So they round down, yes. So that's why we will talk about this next week, like rounding up. So it will round to the nearest number. So epsilon over 2 just round to 0. Okay. So now the next one. So the next question is about some number that bigger than the maximal real number. So now if I share with you the structure of the floating point again. So now share the paper again, yeah. So now, okay, so now go back to the, so this is for the next question, yeah. So go back to the structure of the floating point. Yeah. So now suppose I have real max. Okay. So real max is the maximal real number in the floating point system. So you see, remember like the odometer. So the maximum is when I turn on everything to 1, to the maximal value, right? So 52 digits. And now 2 to the power E max. So what is E max? So E max is the maximal values of the exponent. Yeah. So remember in the diagram we had before, yeah, so we have 11 bits for the exponents. So then what is the possible value? How many possible values for the powers for the exponent? So what is the maximal values for the exponent? 2 to the 2 to the 11, right? So 2 to the 11. So exponent field has 11 bits. So you have 2 to the 11 values. So for the exponent. But remember, you cannot have only positive powers, right? You can have negative powers as well. Yeah. So the IEEE, yeah, decided that. So if you read my lecture notes, yeah, so if I show you the lecture notes in chapter 2, so the lecture notes will be um, so if you read chapter 2, right? So I can share you the lecture notes here. So you see that the E min and E max is given by the IEEE to be this value. So we use double precision, just nobody use single precision anymore. Just for historical reason, we're still there. But you see, the E max is 1023, okay? And the E min is minus 1022. So if you take the sum, you will see that there's only 2046 values, okay? So there's still 2 values left, and 2 values left are for the special case, and they use it for the not a number, for plus and minus infinity, and for non-normalized numbers, and so on. So in the end, the Emax is just 1023, okay? So for the double precision. So now I go back to my formula and I put in Emax is 1023. So if I go back to my formula here, then I'm going to put my Emax is only 1023. And you see that now the real max will equal 1.11111. So what does it mean? This means that in terms of decimal, remember this one is just a binary form, right? So in terms of decimal, then you have 1 plus 1/2 plus 1 over 2 square plus dot, 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 1 over 1 over 2 to the 52, right? Times 2 to the 1023, okay? And if you remember the geometric series formula, then this the last formula will equal the last formula will equal Yeah, this is in decimal, yes. So this one is in binary. Okay, but it means that I convert to decimal. So 1 here for 1, yeah. And after the dot, 1 here, just 1/2. And this one here is 1/4 and 1/8 and so on. So I convert and back to decimal because I want to show you the decimal values of real max. Okay. So everything is clear, yeah? Okay. So now if you remember the formula for geometric sequence, then this one is just equal 1 minus 2 to the minus 53 over 1 minus 1/2, and everything multiplied by 2023. Okay. And I simplify it and then any question? And if I simplify it, then I got 2 minus 2 to the minus 52 multiplied by 1023. Okay, so that is my final formula for real math. And now, if you put into MATLAB, because this number is not easy to compute, okay, you can put in your calculator, but I don't believe that small calculators can compute this number. But if you put in MATLAB, so I put in MATLAB this formula. So I share you my MATLAB here. Yeah. Then I have 2 minus 2 to the minus to the power minus 52. Then multiply with 2 to the 1023. So I got this big number. Okay. So 1.7910 times 10 to the 308. Okay. So if I put in real max, so I got the same number. Okay. So real max is the maximal normalized real number the double precision floating point system can handle. So now what happened if the result is bigger than real max? So what happened if the result is bigger than real max? So that is the next question. So if you go to the next question, you can see that you have x is x is 1e plus 200. So what does it mean? So 1e plus 200 just means that 10 to the 200. Okay. So if you take this number and you take exponent, okay, well actually exponent of x cubed, yeah, then you see that it will be bigger than real max, right? Because you raise to the power 2, then you got the 600, the power is 600 already. So it's bigger than this number. And when you put it in, it just gives you infinity. Okay, so MATLAB reserve the keyword infinity for something bigger than real max. Yeah. So everything is clear, yeah? So how about real mean? So real mean is the same story. I mean, you can do real mean as well, yeah? So real mean is, so suppose I type in real mean and I got this number. So why do I get this number? So now we go back to the piece of paper, yeah? So real mean is you put, so remember the floating point number system. So now real mean you put every numbers are zeros, yeah. And now you put in the power is e mean. right? Yeah, so this one is 52 digits, but it is 0, so just 1. Yeah. So what is E mean? So remember, we got E mean from the IEEE. So if you look at my lecture notes, E mean it just equal. So E mean it just equal minus 1022, right? So minus 1022. So now, so what does it mean? So now if you go to the MATLAB, yeah, and you put in, so I stop. Well, before I put in MATLAB, let me put in the formula for this one. So this one is just equal 2 to the minus 1022, right? So if this one equal 2 to the minus 1022, then I put in MATLAB, yeah. So now if I share MATLAB screen, so 2 to the minus 1022, I get that number. Very, very small number, 10 to the minus 308. It's very, very small number. But then, you know, why real mean is not equal 0? Why real mean is some very small number, but it's still positive? So why is that? I mean, this one is a small number, right? 10 to the minus 308, still very small, but still positive. So why real mean is 0? Why is that? Now this one is not only MATLAB, this one is general for other languages as well, if you use Python. Yes, because the correct answer is because it normalized. Yeah. So because it normalized, so you have the first digit is 1. So you never store the number 1, right? But it's still there. So that's why, you know, I mean, when you put it in the calculation, then you still have that 1, and 1 multiplied by 10 to the E mean, and that this give you this number. Okay. So everything less than E mean, then, you know, so look at this E mean. So how do you get 0? Well, so like I said, remember, so if you remember my lecture notes, yeah, so now let me share you the lecture note. It's a very good question, yeah. So if you look at my lecture note, so you see that in the exponent field, see, you use only 200, you use only 2046 values, right? But remember, you have 2048 values. You still have 2 values left, and that 2 values left is for storing, you know, numbers that not normalized. So like subnormal numbers. So the subnormal numbers start with the 0 digits. Okay. And see, so that in this case, then you can store the number 0. So when the first digit equals 0, yeah, and then in this case, then you can store the number 0. Okay. So you see, if E equals 0 and F equals 0, then you get plus or minus 0, which is still equal 0, right? Because the sign plus or minus, we still there. You see, so that's why, you cannot use E max to be 1024 or E min is minus 1023, you know, because you have to save some extra values for extra case, for some special case. Okay. So now go back to the question. So the next question is, so we have seen this construction before, right? So now I can go back to my MATLAB. So V will be minus 2 and start from minus 2, increase by 2, yeah, and stop at 2. Okay, so start at minus 2, increase by 2, and stop at 2. Okay, and we see this construction already. So I could just give you a vector start from minus 2, increase by 2, and then stop 2. So remember, okay, if I give something like this, so minus 2, increase by 2, but now I stop at 3, yeah, or 3, then what do I get? What do I get if I stop at 3? Yeah, I still have minus 202, right? Because you can see it, because it stopped before it get to the limits, yeah. But be careful if the increment is minus. So suppose I have 2 minus 2, right? And minus 3, yeah. Then you see now it's going down, but it doesn't go to minus 3, right? It just stop at minus 2, okay? But that is, be very careful, yeah. So now suppose I have V is minus 2, increase by 2, and stop at 2. And now I have V divided by square root of V. So you see what is going on here. So V is a vector of three components, yeah. So 2, 0, and minus 2. And when you divide it by square root V, the first entry just give you square root 2 times I, yeah. And then the last entry is just square root 2, yeah. But now how about the middle? Remember the dot here just means that element-wise operation. Take every entries and you divide it by the corresponding entries. So now you have 0 over 0 in the middle. So 0 over 0 is not a number. You see, NaN stands for not a number. Okay. So now the last question is x equal 0.1 and h equal 10 to the minus 18, yeah, and then x plus h less than or equal x. So what is the answer? 0 or 1? So h is a positive number, right? So x plus something positive. Is it still less than or equal x or not? Equal 0, yeah. And it's not equal 0, it's equal to 1. Okay. And why is that? So why is that? You know, I take x, I plus something positive, right? And it's still less than or equal x. Why is that? Huh? Yes, h1 is less than epsilon. So remember the story about epsilon. Epsilon is the gap between 1 and the next number. And here, because h is so small, it's less than epsilon, so this is rounded to 0. So then this MATLAB interpret this one like x plus 0. Is it less or equal x? And the answer is yes, because it's still equal x. Okay, so now suppose I put in h equal 1, I mean 1e minus 15, so 10 to the minus 15. And you see, because remember epsilon is 2.2 times 10 to the minus 16, yeah? And now I ask the same question. And you can see that it equals 0, right? Because now, as you expected, so 1e minus 15 is 10 to the minus 15. So it's bigger than epsilon, so about 10 times epsilon, yeah? So then x plus something positive is bigger than x, yeah? Okay. And now the next question is dealing with you know, special case infinity minus infinity, and not a number or not a number. Okay, so now what is 1 over 0? So this is question 2. Yeah. So you see, I mean, this 1 over 0 is not a number. No, let me type it in. Yeah, infinity. So you see, this one is just to see that whether MATLAB is consistent with calculus. And calculus was invented 400 years ago, and MATLAB was built only 40 years ago. So MATLAB has to be consistent with calculus. And you know, 1 over 0 is infinity, right? So when you take the limit, say 1 over x, x go to 0, it blows up to infinity. Yeah. And then minus 1 over 0 is minus 1 over 0 is minus infinity is correct, yes. Now how about logarithm of 0? So how about logarithm of 0? So remember how the logarithm function look like. Minus infinity, yes, correct, yes. So logarithm, you know, I mean, it's going down, you know, to minus infinity when it approaches 0, when x approaches 0, okay? And now the next question is interesting. So what is logarithm of minus 1? So this one is a test whether you have MATLAB in front of you or not. Not a number. Well, you can try. If you put in MATLAB, then you can try. It's not correct. Pi I, yes. And why is that? Okay, so let me explain to you. It equal pi I, yes. So let me explain to you the complex. Yeah, so it's a complex logarithm of a complex number. So let me share the piece of paper. Yeah. Sorry. I pressed the wrong button. Okay, so now if you remember, or maybe you might not have seen it. Okay, so if you study complex analysis, you don't have to, but I just tell you that. So in this complex plane, yeah, then the logarithm of z is defined to be logarithm of absolute value of z plus I argument of z. Okay, so now what is z here? Z is minus 1. Okay, so logarithm of minus 1 right here. And it will equal the logarithm of absolute minus 1 plus I argument of minus 1. And logarithm of minus 1, absolute value is logarithm of 1. So this one just gives you 0. Okay. And what is minus 1? So minus 1 is this number. Yeah. And the argument is the angle between the OX axis to this vector. So it's just pi. Okay. So I mean, this is, you know, just a formula from complex from complex analysis, but it's not very important. But the whole point is MATLAB interpret everything as a complex number. Okay, so if you put in MATLAB logarithm minus 1, then it will use the formula for complex number. So you see that 0 plus I pi. Okay, so this is a very good approximation of pi. Yeah. And then what is 0 over 0? So what is 0 over 0? So we got it before, not a number, right? So now what is infinity minus infinity? This time must be not a number. Yes, it's correct. Infinity minus infinity, not a number, because it's an indefinite form, if you remember your calculus. And 0 times infinity. So what is 0 times infinity? Not a number. Yes, correct. Yes. Because, you know, it's an indefinite form. You can use L'Hospital rules, but MATLAB doesn't know L'Hospital rules, so just say not a number. So 0 times not a number is still not a number, okay? And infinity over infinity. Well, because infinity over infinity is still not a number, okay? And now what is 1 over exponent of infinity? What is 1 over exponent of infinity? 0, yes, correct, yes. Because exponent of infinity is just infinity. And 1 over infinity is just equal 0. You still remember calculus, very good. And now what is 3 times infinity minus infinity? So what is 3 times infinity minus infinity? What a number, yeah? Because infinity, 3 times infinity is still infinity, and infinity minus infinity is not a number. So now how about 3 times infinity plus infinity? So now what is the correct answer? Infinity, yes, correct. Infinity plus infinity is infinity. And now not a number minus not a number is not a number, okay? So everything is consistent with calculus. Okay, so now what is the output from the following MATLAB command? So this one we saw before, yeah? So 4 minus 2 minus 3. Then you see start from 4. So you increase by minus 2, means that you step down by 2. So for 2 and then 0. And then remember, step down to minus 2 and cannot step more, because if you step more, then minus 4 is beyond minus 3 already. Yeah. So then stop it here. And now the next question. So the next question, so let me explain to you before we type in MATLAB. Yeah. So let me share the piece of paper. So the next question is you have a vector, right? You have where is my question? You have a vector 1, 1, 4 transpose multiplies by 1, 3. Yeah. So so 1, 4. Yeah. So this one is just the column vectors 1, 2, 3, 4. Right. Well, because first you got a row vectors with the prime here, transpose it into a column vectors, yeah. And this one is just a matrix of 1 row and 3 columns, and every entry is 1, yeah. So you have 3 ones. And remember your matrix multiplication. So this one is 4 times 1, and this one is 1 times 3. So you should get a 4 times 3 matrix, yeah. And now remember your algebra. So you take 1 multiply with 1, right? And because there's no other entry, so it becomes 1 here. So then 2 multiplied by 1 give you 2, and 3 multiplied by so 3 multiplied by 1, so give you 3, and 4 multiplied by 1, so give you 4. Okay, so you do the same with the second column. So 1 with this 1 give you 1, 2, 3, 4. So the same, so 1, 2, 3, 4. So this one is a 4 by 3 matrix. Okay, and you can, so this is the correct size, yeah. And you can verify it with MATLAB. Okay, so now if I put in MATLAB, then you can see that it will be as you expected. So 1, 1, 4, 1 to 4 prime, yeah, times 1, 1, 3. So it gives you the 4 by 3 matrices, yeah. So if you remember your linear algebra, then from the formulas in MATLAB, you can compute the output easily. Okay, so this is the type of problems in the past exam papers, you know, when you was in the exam room and there's no MATLAB and you have to do some simple linear algebra like this, you get the question done. But now because of COVID, so everything will be online. So, but the question is still there, yeah. And anyway, we just need to understand what is going on, yeah. So now the next question is, so it's clear, right? So any question? So far, so good, yeah. Well, because, you know, I mean, the exam will be online. So even if I say that, do not look at MATLAB, but, you know, I mean, it's online, you can do whatever you want to. So, but you see, the exam will be slightly different this year, okay? So the exam will have no MATLAB questions, okay? Or the MATLAB question will be something, you know, tiny credits, you know, so half a credit or something like that. Yeah. We adapt with the COVID situation, you know, so not a big problem. Anyway, so now go back to the question. Lin space. Okay, so lin space is, you know, the command lin space just give you, say here is 0, 10. So it, it will generate 5 points, evenly spaced from 0 to 10. Okay. And what does it mean? So if you take the intervals 0 to 10 and you divide it into 4 equally intervals, then you got 5 numbers. Yeah, so 0, 2.5, 5, 7.5, and 10. So very simple. And now the next question is show you how you can, you know, like cut and paste the vectors into the matrix. So now you have an identity matrix. So I stand for identity matrix. So they cannot use capital I because capital I reserved for complex number already. So they use the command I. You know, I, the name sounds like identity, but the words are different. So I3 just give you 3 by 3 identity matrix. And if you have a vector 2 to 4, so this one just a row vector, okay? And then V will be 3 to 6. And remember, transpose become a column vectors. Yeah. Now A is, you just take the original matrix A, and semicolon and U just mean that you put the row vector U underneath the matrix A. Okay. And you put it back to the matrix A. So you see the matrix A here, yeah? And now the vector U here. And you just stack U beneath the matrix A. So you got a new matrix like this. And then after that, you have a matrix A. And you just take the column vectors V, right? You put it next to the last column. And you get a new matrix. So this one is the new matrix. Okay. And so now the next question is, you can type it in, you can see the output, but let me explain what is going on. Yeah, so I explained by pictures before we start doing the MATLAB, because you put in the MATLAB, you get some matrix, but you don't know exactly why it's there. Let me share the piece of paper again. So now we have a matrix C. Okay, so if you remember the command, the matrix C will be 1, 1, yeah, 1, 1, 1 here. So just the matrix 2 by 3 matrix, and all the entries are 1. Yeah. And now the matrix D is twice the matrix C. So just take every entries multiply by 2. So simple. Okay. So now the tricky part is the matrix E. So the formula for the matrix E is given like this. So E is open bracket, C and D, then 1, 2 in bracket, 1, 2 in brackets, then colon, then 3 times 1, 2, 5, yeah, and square bracket, and 4 times 1 for 1. Okay, so you see my formula, right? So you see my formula. Okay, so maybe the last bit is not visible. Okay, so this is the last bit, yeah. So now we will construct the matrix E. Okay. So now I will take the matrix C first. So the matrix C will be 1, 1, 1, 1, 1, 1. Yeah. So this one is the matrix C. Come from here. Okay. And so this one, what does it mean? This one just means that the matrix D. But you take only row 1, row 2. So 2 rows. And only column 1, column 2, 2 columns. So the submatrix that contain rows 1, rows 2, and column 1, column 2 are this matrix. Yeah. And so because it's a space, so you just put it next to each other. So you have 2, 2, 2, 2. And then I made the oval shape, say that it comes from here. Okay. And now you see the semicolon. The semicolon means that this one will on top of whatever come after this. Okay. And come after this. So on top of this is a matrix of size 2 times 5. Yeah, so 2 times 5. So 2 rows and 5 columns. Okay. And what are the entries? So you can see that the entries are ones and then multiply by 3. So all the entries are 3. Yeah. So it will become 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Okay. So this come from this part. Yeah. And so you have to build up the first submatrix already of the matrix E. Okay. And now, so you see the space here. So the space here means that you just put as the next columns. Okay. And what is that? It's a 4 by 1. So 4 by 1. So 4 by 1. And what is the entries? What are the entries? The entry is just 4, right? So 1, 1, 1, 1, but then multiply by 4. So you got 4, 4, 4, 4. Yeah. And I claim that this is a matrix E. So I claim this is my matrix E. And you can type in MATLAB and see whether I get the correct results or not. So this is my matrix E. Okay. So I can show you when I put in MATLAB, I will get exactly the same matrix. So if you take a screenshot of that matrix, now I can type in my formula. So if I stop this, then I share with you my MATLAB. Then, so again, so C, so that C is 1. Yes, this symbol prime does conjugate and transpose. Yes, it's correct. Yes. Okay, so symbol prime does conjugate and transpose, but because it's a real matrix, so everything, you know, just the conjugate is still the same. So just transpose. Yeah. Okay, so now let me type in this matrix C. So 1, 2, 3. Okay. So this is my matrix C, and then matrix D is just 2 times C. Okay. And matrix E is just C, D, 1, 2, 1, 2. So you have to type in, you know, very carefully because otherwise it will not give the correct results. So 2, 5, 4, 1, 4, 1. And I hit the enter. And you see that it's exactly what we expected. So you see, I mean, this formula just show you that MATLAB is very, very flexible with, you know, like cut and paste the matrices. It's like a puzzle. So with just a single line, and you can see that so many operations going on at the same time. Yeah. So it's not very intuitive, but when you draw pictures, you will see it. Okay. So any question? And now the next question is, let's show you how to take our submatrix. So a matrix F, okay, is, so now let me go back to the piece of paper again, and or maybe we can type it in, we can see it right here. Yeah. So E, so this one, it just means that you take out rows 2 and 3 of the matrix E. And then in rows 2 and 3, you take out only column 3 to 6. So you see that column 2 and 3 right here. So 1 and 3 here. Yeah. But you take out only from column 3 to 6. So column 3 is here. So you got 1, 3, 2, 3, 2, 3, 4, and 4. Okay. So that is how you get the matrix F. Okay. So maybe there's time for one more small question. Okay, so compare the linear space and the vector construction. So you can see that so if you have x is 0, 0.2, and stop at 1, then you see that it will give you all the points from 0 to 1, and the increment is 0.2. 0.2, 0.4, 0.6, 0.8, and 1, okay? And then if you put linear space from 0 to 1 and 5, you know, if you put in 5, then it divided into 4 equally spaced intervals. And you got 0, 0 0.25, 5, 0.5, 0.75, and then 1. So if you want the two give the same answer, then you have to give 6 intervals. Sorry, yeah, not 6 intervals, but six numbers. Okay, then it will be the same. Okay. So I don't think we have time to go to question 5, but I think I will post the solution. So any questions? Any? So let me stop the recording and you can ask questions. So stop this one and stop the recording.